Let's continue the real option example. So extraction rate 10,000 ounces per year and extraction cost is $200. And currently gold price is $400 per ounce, and then when it move upside is 1.2 and downside is 0.9, and risk-free rate, gross risk-free rate is 10%, and then therefore risk-neutral probability is risk-free rate minus downside over upside minus downside. Okay. This is the most important part. Let me highlight. I can highlight anyway. And then there is also new technology. If we use new technology, the extraction rate is $12,500 per ounce. We can extract more. But price of the new equipment, in order to install new equipment, we have to pay $4 million. $4 million. So clearly, intuitively, if gold price goes up, right, we can extract more. Okay, you can extract more. Therefore, it is likely to install new technology. But anyway, the new extraction cost, if with the new technology, is $240 per ounce. Okay, so intuitively, if gold price go up, maybe we want to use new technology because it extracts more. It is slightly more expensive. Extraction cost is high, but if you think about it in terms of per ounce basis, right? Per ounce basis, let me think about it. In terms of per ounce basis, extraction cost of old technologies, this one, right? $25. And then for new technology, extraction cost is, let me see, extraction cost is what? Okay, per ounce basis, not right. Per ounce, per dollar, it extracts 52 ounce, and then for this one, per dollar, it extracts $10,000, right? So per dollar basis, new technology is more efficient, right? Per dollar basis, although it's more expensive. So since it is more efficient per dollar basis to extract new gold, therefore if gold prices go up, then we want to install this technology. And then we developed the gold lattice, which was easy. We start from $400 and going up. First we fill this one, going down, and we fill the others. And for risk value, what we did is we first compute the value of gold we extract this year, which is quantity multiplied the max of the amount of quantity, max of the price minus cost, because it's gold price is less than cost, we wouldn't want to extract. So it is 0, max 0. So it is quantity, this is revenue of this year. But since gold arrives at the end of the year, so we have to discount it back. So it's in the beginning it is the revenue, discounted revenue of this year. Okay. So this whole term is revenue this year. And because we want to calculate everything in terms of $1 million, we divide with 10 to the power of 6. So this part is easy. This part is the revenue of this year. And then since it is the gold mine and it will produce gold next year, the year after next year, blah, blah, blah. So there is also continuation value. For continuation value, we have two possibilities. It can, depending on gold price going up, gold price going down. So this is gold price going continuation value under the scenario that gold price go up, so we multiply that by Q. And this is continuation value under the scenario of gold price going down, and we multiply risk neutral probability of gold price going down. So it is expected continuation value of the next year, so we discount it back. So sum of this year's revenue, actually profit, sorry, it is minus cost, so it is not revenue, it's cost. Sum of this year's profit plus the continuation value determines the risk value of the gold mine this year. And then we do the backward induction continuously, then we can compute risk value in the beginning of the year. On the new technology, clearly it is more intuitively the mine value of the mine would be higher because per dollar basis we extract more. But it doesn't mean that we have to install right now, because in this case we have less than $3 million increase in gold mine, but technology cost of the new technology is $4 million, so we don't want to install right now. But it does not mean that we don't install it forever, right? In the time in future, sometime maybe it is better to install it, right? So we have to take into account the option of installing new technology. So if we take into account the option of installing new technology, then maybe mine price would be somewhere between this one, right? And then the answer is 24.63. So it is slightly higher than this. It is much higher than this one. Okay, this is without option, and then this is with the option. Okay, so it is more expensive. Gold mine is more expensive. So this is the difference between the two. The option value. Option value is $0.6 million, right? So it is not small. So again, I'm not using the technology right now. There is just the possibility of using new technology. And that possibility, the value of that possibility, $500,000. Okay? Then how we can calculate this? Okay, so this is not, that shouldn't be difficult. Again, it is the same. Okay? First, of course, we start with the backward induction, so we calculate the continuation value. Okay, so there is a continuation value. We compare this one and this one. This is the value going up, and gold price going up, and this is the gold price going down. Okay, so this is the I-49. So offset I-49, and then going up, then it is -1 plus 1, right? Oh, offset, I don't know what is going on. Strange. So this is the I-49. This is right. This is strange. Offset I-49, and then going up. So one row go up and one column going left. Okay, now it is working. And then offset I-49, and then now going down, so it's 0, same row, and one column right. Okay, so it is continuation value, this one, and then because it is next year, we have to discount it back. Okay, and then for this year's value, then again C1 is the quantity. Okay, this is a quantity multiplied by I-13 is the price of the gold. This is, where is it? I-13 price of the gold. So I have to go to the, where was it? Was this one? Okay, was this one? Okay, so this is again today's revenue, so quantity, and then C2 was the cost, right? C2 is the cost. This is confusing, so I have to change everything. Cost, right? cost. So again, this is this year's profit quantity, and then price minus cost. And of course, if cost is greater than 0, then we do not extract it, so it is 0. And divided by this one, J1 is risk-free rate. Right? RF, risk-free rate, and then same. But thing is that now, so this is a continuation value given this technology. This is the profit given this technology, right? Profit given this technology, the continuation value. But problem is that we can install technology right now. If we install technology right now, then we have to use this. We have to use what? This is the, yes, this one. We have to use this one, right? This is the value of mine when we have a new technology, given this continuous value and everything. So if we invest, then we move to this one. So we have to compare, okay, value under this new technology and the cost of investment. So we basically compare this one and this one, this entire thing, right? This entire thing, okay? So it is a max, okay? And then we do this one. Right? Okay. So do you know what is going on? So it should be any question? So it is almost similar to the previous case. It is the expected value of continuation value, and it comes back and calculates today's profit on the old technology. And then this, we have to compare this entire thing with the value of gold mine on the new technology minus investment, right? And then we choose bigger one. It's okay. Any question? Is it fun?
Do you think that really people calculate it like that?
Oh yes, it is very useful technique. Actually, I was a management consultant before I studied academic career, and at the time it was a dot-com bubble. And then I have to do the valuation for a lot of dot-com internet companies. And the problem is that all those new internet companies, they don't simply have any customer and any profit. So there is no future cash flow to discount, right? But we have to come up with the numbers for the valuation. And do you know what we did? We used this real option technique.
No, but I mean, like for this drilling business.
Oh,
Like oil or whatever, gold.
I don't know about that part. I'm not an expert in gold business, but I think the real life, it should be much more complicated, right? Because there should be uncertainty about the new technology. But yeah.
Did you change the new quantity of session or it was?
What do you mean by?
I think that you are using the last.
Yeah, so it is the old quantity of the old technology, and then old technology profit. So this from here to here, it is a profit from old technology. But this continuation value, of course, include the option value as well. But anyway, we have to compare this one. This is the value on the old technology, and then this is value new technology. So we have to compare these two. About this new quantity thing is included in this part, right? This A41, I think. Right? A41 is this one, and in this case, there's a quantity new. And then let's figure out when this option is exercised. It is not difficult because, okay, this is the basically we compare max of the value under old technology and then old technology and new technology. So by subtracting, what we can do is we subtract this one from this one, right? Basically, we want to compare whether this one is big greater than this one. So if we subtract this one into this one, okay, then right. And what we did is we can just copy and paste this entire thing. Okay, we can copy and paste this entire thing over here. Equal, and actually it should be minus this entire old value. There is a problem with the formula. What is the problem? Okay, so yeah, good. And then I do this one. Let's do this one. So basically, I'm recycling this one, right? I subtract this one from this one, okay? And then if this part is greater than this part, then it means option is exercised, so it should be positive. And then it is mostly negative, but there are some places it is actually positive. So how can I say if this is greater than 0, no, then it is the, okay, I want to do it manually. So let's say this is positive, so positive. Okay, so they are positive, right? So highlight. Okay, they are positive. It means any other else. So yeah, when gold price reaches this point, then actually option is exercised. So this is option exercise boundary. So option is not always exercised. So imagine if there is no this blue area. If there is no blue area, then this should be 0, right? This should be 0. In some sense. No, this is not 0. This should be exactly same to the previous one, right? Because if there is no this blue area, it means that there is no possibility of exercising option. It means that the option is useless. If the option is useless, then this one should be equal to this one, 20.4.1. The without simply the case of gold mine. But because there is a possibility of exercising option like this, then option is valuable, therefore the value of the gold mine goes up. So if you own gold mine and if you want to lease someone, and if you know there is a technology, then you have to lease at the price of this one, okay? Any other question? Oh, this is actually very useful. Many people actually use this technique. Okay, good. Let's go move to next topic. I think it is enough for real option. Okay. And then next, I want to show you how to use Excel solver and therefore using computing implied volatility. So let's use an Excel file. Okay. Now it is time to use computer. Have you ever used the Excel solver before? Excel solver, right? Excel solver is very useful technique. Have you ever? Yes, you are from engineering department. So how can let me show you first minimization example. Minimization example. Oh, I have to save file, option, and then 추가 기능. Okay, everything is there. And then this one and then this one. First, let me show the minimization. So suppose A is 1, B is 2, and then X is 2, Y is 2, Y is 10 maybe. So this is a function. Let's write the function such that function is Y equals X minus A square plus Y minus B square. Okay. And then this is the simply X minus A square plus Y minus B, Y minus B, where is, Y is this one, Y minus B square, right? Then it is 65 because it is 1, 2 minus 1 square is 1, 10 minus 2 square is A square, 64. So 64 plus 1, 65. So what do I do? I want to minimize this function. Okay? What is the solution for, what is the solution of this minimization problem? 김민영. What is the solution for this minimization problem? If we want to minimize this, why? What is the answer? Usually AB is constant and you change XY, right? Oh, okay, then it is V. Okay, this should be V. How we can minimize this V? What is the solution for this one? So what should be the answer? 그래서 미니멈 밸류가 뭐냐고, 최소값이 뭐냐고, 이 함수에. Okay? 그래. When does it become 0? Yes, exactly. Yes, that's what I'm asking. And then this is of course easy problem. So we can solve it by just even without using pencil and paper. And Excel actually do those things. Okay? So we can go data, I think, solver, and bigger pardon?
0 when A is equal to X and B equal to
I mean, let's say A and B constant. So when X and A become same and Y and B become same, it is 0, right? So let's minimize this function with respect to X and Y. So A and B are constant and we change X and Y and we want to minimize it. Then clearly the answer is when X is A, Y is B, it becomes 0. And that's the solution. Excel does that. Okay, so data solver, and then we do the minimization and target. Our target is this one. We want to minimize this one, and by changing, we want to change this and this. Okay, and to 0. Okay, x is 1, y is 2. And then now let's impose a constraint such that, let's say x should be greater than equal to x should be greater than equal to 2, 10, and if this is should be less than equal to minus 10. Okay, again then, okay, in the previous case is not it is the simple minimization, but now we have a constraint minimization. Okay, so such that x should be greater than equal to 10 and y should be less than equal to minus 10. Then what should be our answer? Then what should be the answer? Yes, x10, y minus 10, right? You know, this is like a ball shape. Okay, ball shape. So we have to be as close as possible to the value of a, b. Right? The closest value given this minimization is 10 and minus 10. So let's do that. So again, data, 해찾기, and then now there is a constraint. Constraint insert. So let's say this one should be greater than equal to this one, and then this one should be less than equal to this one. Okay, so we added two constraints. If we run it, well, there is a problem. It is the B6 greater than equal to D6, B7, and then we have 최소값. 네? What's wrong with this? 잠깐만요. 네. 네, okay, sorry. Yeah. And then this one done, right? This is 10 and minus 10, so answer is 225. Okay? And then, of course, we can do the maximization. For maximization, let's say we can simply put minus over here. Okay. Minus, and then let's change this one like a 5, 5. Okay, 5, 5. And then we know that this is now maximization problem, so answer is 5, this should be 2. Okay, so error and 해찾기, save and 최대값, save, done. Okay, so this is actually, what is this one? This is strange. Right? There is something wrong with this should be 5. X should be 5, right? This is weird. 최대값. 네? This is very weird. What's wrong with this Excel? It cannot solve this simple problem. I mean, 다른 컴퓨터로 돼요? 여러분 컴퓨터로? How about your computer? Does it work in your computer? Really? But GRG 비선형 is more robust. Okay? This is simple linear programming. Wow. It doesn't make sense. Okay, now let me try. And then change it. I don't know. This is very stupid. Does this same problem happen to your Excel files? Huh? So it works for you, okay? Is it Apple? Oh, no, it is, okay. I don't know. But anyway, yeah. How about in your computer? Does it work? Okay. Yeah, you have to install solver. Okay, so you can use solver this way. And then in Excel Visual Basic, we can also use Excel solver. Actually, we can do the programming for Excel Visual Basic. So I have a simple program. Let me change this one again. Why? I mean, this is strange because minimization works, right? But because of the same thing, right? And then maximization doesn't work, so okay. Right? It is very strange. I mean, it is a minimization and maximization should be exactly equivalent because I just put minus and so anyway, it's a good lesson. When you want to use Excel solver, please use minimization. Change everything to the minimization problem because I don't know, somehow Excel deal with minimization problem much better than maximization problem. I don't know why, but okay, let's see. And then in order to use Excel solver in Excel macro, we have to save it into the macro 사용 통합 문서. And then solver, okay, solving. And then this is again minimization problem. And then 개발 도구. Let's use Excel Visual Basic and then add module. And then in the class web page you can copy and paste this one. Okay. And then first one is the just name of subroutine, and then you have to solver reset and solver option. This is I don't know, but we have to anyway. We have to put this on in order to make it work. So write down solver reset and solver option precision is 0.001. So it means that I make my solution as precise as this margin of error. Okay, so you can make it even smaller than that. Okay, let's put one more zero over here. Then my solver becomes more precise. And then solver OK. Again, this is the rest language. And set cell, it is target cell. And target cell is, in my case, my target is this also. So cell 9 to cell 9 2. Right? And max min value, this is the I forgot, but Excel VBA solver, and then if you solver OK function. So okay, max min value. So this is a minimization problem. So it is 2, right? Minimize. So max min value 2. Okay. So if I set this one as 1, it is maximized. 2 is minimized. 3 is match specific value. In this case, we know our minimum value is, right, minimum value is 16. So maybe we can set this one 16. Then it becomes, again, identical problem. But anyway, make it 2. And then by change, we want to change this and this. So B6, B7, right? B6, B7. And relation 2 is, what is the relation? Okay. Solver add relation 2 is the solver add function. We go to solver add, and the relation is 2 is equal to arithmetic relationship relate to equal 0. No, I don't think I need this one. Okay, we want to change this one, so let's ignore this one. Okay, so if we run this program like this one, and then solve, user finish. So if you make it true, then there is a message pop up. If you make it false, there is no message pop up. So actually, this is all we need. Okay, this is all. Again, we solve the solve option precision. We make our solution as precise as this one. And our target set is now in 2. Our target set is 9, 2. And then minimize, which is maximum value 2. And by changing this one, okay, by changing B6, B7, by changing what? What is the B6, B7? Right. Somehow this is the, again, this is the, I don't need this one either. Okay, so by change B6, B7, B6, B7, and the engine is 1. Okay, solver okay, and then where is the solver okay function? Solver okay. If you go solver okay function, okay, solver okay function, then minimize, maximize, and then where is the engine? Okay. Okay, by engine option variant, the solving method should be used to solve the problem. 1 for simple LP, 2 for GRG non-linear function. In our finance example, most of our problem is a non-linear problem. So I usually set this on 2. Okay, so engine is what? It is 1. It is the, okay, 1 is simply is 2. Yeah, so it should be 2. Okay, it should be 2. Engine is the second engine, GRG non-linear. Or engine decision is GRG non-linear. So it is alternative way. So that's the solving method. And then by change optional variance, an alternative way to specify solving method that should be used to solve the problem as string GRG non-linear. Corresponding select the solving method. So they are same. So you can pick either this one and this one, but actually I choose this one, both of them. So, but anyway, it is unnecessary now. So, and then strange. Okay. Didn't I save it? Okay. And then let me make a okay. What is going on? Strange. Okay. Let me run this one over here. Solver is set. reset VBA. Solver reset function. Solver reset function is reset all cell selection constant to solver program dialog box. Restore all the settings in the solver option to their default. Ah, strange. Let me and then run this one. Ah, annoying. Why it doesn't work? Okay. Close the program and open the program again. 매크로 시트를 참고해야 합니다. How about you? Does it work in your same problem in your case?
It has to be related to macro.
Okay, then I'll use trick. Let me use a trick. Okay, so model 2. 네. 그런가? 그래야 되나? 원래 안 써도 됐는데. 잠깐만, 혹시 모르니까 이거 다 지워버리고. 아, 이제 또 되네. 그러네. 최보기 학생 말이 맞네. Okay, I deleted unnecessary sheet and it works. Okay, so, okay, I deleted this one. Okay, module 2 doesn't necessary. This is the I want to delete, but somehow it doesn't work. Anyway, so it should work now, I think. 서로 지정, and then this one. Yeah, I mean, what is going on? Okay. And solve for example, new. Okay. And then I think, okay, I think there is a, I think we have to use this one maybe, solver. I think we have to set up something. Beg your pardon?
Maybe to set that function.
Just a moment. So function not defined, we have exactly the same. You have to install and add in tools. Okay. We have to go tools and then tools and what? I have to go tools, tools add in and solver add in. Strange. Where is it? Where is it? Tools. Okay. I think solver add in. I think I did this. And then tool reference solver. Okay, tool reference. Okay, tool reference and then solver. Okay, let me try this one. 사용 조건이 만족되지 않습니다. What? Let me. It works now. Okay, so we have to install another thing. So again, go to the tool reference and click solver over here. Okay. Okay, so it works. Okay. Okay. Did you set up your, okay, did you set up your, go to the, no, it is, it is Apple, so I don't know how to use this. So, 예, 셋업 했어요?
그거 근데 이렇게 나오.
뭐, 미니마이제이션, 맥시마이제이션은 좀, 뭐, 거의 비슷하네. 프리시전을 더 작게 봐요. 프리시전을. 그렇잖아. 0.00001 해서 정확하게, 거의 정확한 값이 나왔잖아. 프리시전을 더 낮춰야지. So does it work? Okay. Good. So is it okay now? I think F should be similar. But okay, you are helping her. Okay, please. So, Nicholas, is everything okay? No, not okay?
I mean, you still have to set up the normal solver now, and
Yeah, I mean, this is German. So. Okay, so we did it, and then as a next step, we can do the constraint optimization. So it is global minimization, right? But we want to impose conditions such that x should be greater than equal to 5 and y should be less than equal to 2. The solution for y doesn't change, but solution for x should be 5, right? And then how to do it? It is easy. We can go to previous one, code again, and then we can use a solver add. Okay? We can use a solver add, function called solver add. So if we use a solver add, okay, solver add, so cell reference range is the cell reference what? This one is the B6, right? B6, and then solver add, you can go to here. Where is the solver add? Solver add function. Okay, if you go solver add, then it should be less than what? It is greater than equal to, relation is 3. Relation is 3. So relation is 3, and then it should be greater than 5. Okay, 5. Strange. Anyway, 5. And then we want to add another condition. We now is the B7. Okay? B7. And then relation is what? Relation is now less than equal. So relation is 1. And then formula text is again 5. And then we can run. Done. Right? So this x is 5 and y is 2. So we can do the constraint optimization this way. Cool? So again, I mean, using VBA for Excel solver is much easier than Excel solver directly in the Excel sheet. Sorry, I can move this one. Let's copy and paste this one. I think this is cleaner example than the previous one. And then, okay. So in the course web page, you can copy and paste this one. 유정빈, yeah. I moved the program in the course web page, so you can copy and paste this one to your.
But because I don't know where to find the.
Yeah, reference and the solver. First, you can go to the Excel again. Go to the Excel. Please go to the Excel file. Cancel. Go to the Excel, and then maybe Excel. File. Where is the option? No. Properties. No. You can go Excel again. Preference again. This one, Apple mark. I mean, what I'm thinking is you have to find this one, okay? You have to find, okay? You have to go to the file. In case of files, this one, option. You have to have this one. I don't know how to find it, but go to the Excel, and then can you go to tool maybe? To add-ins, okay? You go to add-in, solver, click, okay? Can you go to tools again? 여기 tool. Choose the add-in. Okay. Tools add-in again. Yeah, click. And then select. Did you select all VBA?
This is the file in my computer.
Okay, then go out and okay. Okay, and then you can go to the solver, Excel VBA again. And then go to the reference tools over here, and then reference working, and then solver. Okay, and then can you run the program? Click this one. Run. Okay, go to the Excel file. Runtime error, application defined or object defined error.
Because
This one?
Okay, you can copy and paste. You have to copy and paste the. You can go to course web page and copy and paste the code. Copy and paste the code, and then this page should be same. So it is very hard to run. I didn't know that I have to set up the solver in the Excel VBA in the reference. But anyway, is it okay?
It runs, but the answer's wrong like you have, but at least it's running.
In running, but answer is wrong?
Yeah, like you had, like you have now 0.999.
Oh, you have to increase the precision. Go to the code. Okay? Go to the code and increase precision. Okay?
Decrease?
Yeah.
So
No. To increase zeros. Yes, and then run again. Save and run again. Okay, and it should be much more precise now. Okay? Okay, so it is matter of precision. Okay, so it is slightly behind schedule, but next week we will now run using this solver in order to find implied volatility of the options using flexibility formula. Any question about what we learned today?